All right, here's the solutions for the 2.3 warm-up. So number 1 says to divide the polynomials. Because this has an exponent that is bigger than 1, we cannot use synthetic division, so we're going to use long division. So first I'm going to write the dividend, so x to the 4th minus 2x to the 3rd plus x squared plus 2x minus 8. If there was terms missing, I would have included them, but there's not this time. And then the divisor goes on the outside. We are missing the x term, so it's going to be x squared plus 0x minus 3. And then it's first into first. So what do I have to multiply x squared by to get to x to the 4th? That's x squared. We're going to multiply it times all three terms. X squared times x squared is x to the 4th. Then when we're multiplying x squared by 0x, so I get positive 0x to the 3rd. And then x squared times negative 3, so minus 3x squared. Then we want to change our signs and add. This should cancel, and it does. Negative 2x to the 3rd plus 4x squared. Bring down the 2x and repeat the process. So now I want to multiply x squared by something to make it negative 2x to the 3rd. So minus 2x. Distribute that to all three. Negative 2x to the 3rd. Negative 0, or positive, doesn't matter, 0x squared. And positive 6x. And we change the signs. These cancel. 4x squared minus 4x, and bring down the last one, which is the minus 8. Then first into first again, I'd have to multiply by 4. 4 times x squared is 4x squared. 4 times 0x is 0x. And 4 times negative 3, negative 12. And change your signs. Cancels. Negative 4 plus 4 would be the remainder. So this answer gets written as x squared minus 2x plus 4. The minus that's over here, we'll write it this way first. Plus a negative 4x plus 4 over x squared minus 3. Now, if you take this negative off the front to put it here, then it changes the sign of this as well. So it would be x squared minus 2x plus 4 minus 4x minus 4 over x squared minus 3. Either of those answers, though, are acceptable. All right, number 2 says use synthetic division and the remainder theorem to find the value of f of 2 for the function. So this is where we're going to use synthetic division by putting 2 on the outside, making sure these are in decreasing degree, nothing's missing. List the coefficients. 1, 1, negative 11, 10. Bring down the 1. 2 times 1 is 2. Add them, 3. 2 times 3 is 6. Add them, negative 5. 2 times negative 5. Negative 10. Remainder is 0, and that is what we use as the answer for f of 2. If I was to just divide, then the negative 5 would be the constant, the 3 would get the x, and the 1 would get the x squared. But when you're using the synthetic division to find the value of a function, then you're just using the remainder. All right, number 3, this says using f of x equals x to the 3rd plus 3x squared minus 4x minus 12. Find all the possible roots and then the actual roots. So while this question is factorable, and you can actually factor it by grouping, the one on your test will not. So we're going to pretend like it's not. We're going to go through it the long way. So plus and minus last over first gets me all my possible roots. This is 1 and 12. So the factors of 1 are just 1 and 1. 12 would be 1 and 12, 2 and 6. 3 and 4. So I do plus and minus 1, 2, 3, 4, 6, and 12 all over 1, which means my possibles are plus and minus 1, 2, 3, 4, 6, and 12. Now, before I start testing them out, what I would do is review your Descartes rules. So if I look at the sign changes, if I leave them as is, this is positive, it changes to negative. There's one sign change, stays negative, which means there has to be one positive 0. So when I'm using these to test them out, I would start with all the positives, do all the positives first, and then switch to negatives. So I'm going to put a positive 1 on the outside, and I get 1, 3, negative 4, negative 12. Bring down the 1. And that's not a remainder of 1. So I'm going to go to 2. And that gives me a remainder of 0. So I know 2 is one of my zeros. I'm going to take what's left, ignoring the remainder, write it as my polynomial. So 6 is the constant, 5 gets the x, 1 gets the x squared, and I have x squared plus 5x plus 6. And at this point, these will either be factorable or you'll be able to use their even root property if you didn't have an x term. This, I'm looking for the factors of positive 6 that sum to positive 5, which would be 2 and 3. And then I'm going to split and solve this. And I get x equals -2 and x equals -3. I could have also used a quadratic formula on that. As long as I reduce it down to a squared term, I can then factor, use the quadratic, or even root. One of those will work. So my 3 zeros are 2, -2, and 3. All right, now we're going to finish up the last part of 2.3, which was polynomial and rational functions. That last topic, which is lower and upper bounds. So you won't get tested on lower and upper bounds, but lower and upper bounds will help you to eliminate your possible zeros. The rule is this: if what you're dividing by, so when you're dividing by x minus c, when we do synthetic, whatever, we change the sign, so we put c on the outside. If that's a positive number, and then when you look at all your solutions, that the solutions at the bottom are either positive or 0, then c is an upper bound. And that means that no value bigger than c will work as a 0. If c is negative, and the last row on your synthetic division alternates positive and negative, and 0 can be either, then c is a lower bound. So it would look something like this. If I had a number, let's say I had 2 on the outside, no matter what values are here, what I'm looking for is this bottom row. If the values in that bottom row are all positive or 0, so if it was 1, 0, 3, 0, like that, then I would know 2 is an upper bound. And if there was any other numbers in my possible bank bigger than 2, I wouldn't try them because I would know nothing bigger than 2 can work. It doesn't mean 2 is going to work, but it means nothing bigger than 2 it could work. Now, if that number on the outside was a negative, so let's say it was -2, and again, I had all my numbers here, and I worked through my synthetic division, and it alternated positive, negative, positive, negative, and again, 0 can be any of these, then I would know that -2 is a lower bound, and then I wouldn't try anything less than -2 because I know it wouldn't work. So in this example, which is 10, it says use the synthetic division to verify the upper and lower bounds of the real zeros of f. So it's actually telling you, here's your function, and A says there's an upper bound of 1, and B says there's a lower bound of -4. So you're just proving it by doing synthetic division and then paying attention to the bottom row. So I'm going to put 1 on the outside. 1, 3, -2, 1 are my coefficients and my constant. Bring down the 1, multiply by 1, put it in the next column and add it. Multiply it, put it in the next column and add it. Multiply it, put it in the next column and add it. And all of these signs are positive, which proves that 1 is an upper bound. Then I go to B. Put -4 on the outside. 1, 3, -2, 1. Bring down the 1. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. And my signs alternate positive, negative, positive, negative, which means this is a lower bound. Okay, that's it for today's video. So use the remaining time to work on your 2.3 homework. Make sure you submit the warm-up to today's assignment. And then 2.3 goes also in a separate assignment that will be due tomorrow at 8 a.m. Have a great day, guys.